Yeah, it has started. Now, what is a lightning arrestor? Lightning arrestor is a device that is connected with your transmission line. Basically, near your these are not lightning arrestor. These are actually some rod that will collect the lightning. These are the lightning arrestor. Can you see that? This is the tall insulation type. These are the lightning arrestor. What they does actually, they have very high amount of resistance in between them. Very high amount. Very high amount means that is almost infinite, almost infinity resistance in between them. But when the voltage is lower, that means that your normal transmission voltage, when you have just your transmission voltage, that time their resistivity is much higher, almost infinity. But when the voltage is bigger than certain amount, like when the lightning struck, when the lightning hits your transmission line, that time the voltage become higher, because lightning is million volt, right? When you have million volt, their resistivity becomes zero. They have a variable resistivity. When the voltage is lower, the resistivity is infinite. When the voltage is higher, the resistivity is lower, just like zero or something like that. When they have a voltage of 0 volt, when they have a resistance of 0 ohm, that time all the high voltage will go and discharge to the ground. Okay, let me show you by using some drawings. I'm going to draw something. No. Now let's say this is your transmission line, right? This is a tower. It's another tower. This is the transmission line. Understand? Now what happened? Let's say if a lightning struck here, this is the lightning. What will happen? Normally the voltage was let's say 132 kilovolt. 132 kilovolt. Now when the lightning struck, that time the voltage become million. 1 million volt. 1 million volt or 2 million volt. 2 million volt is huge. So if you do not discharge this voltage, what will happen? This will go to your consumer end, and that will burn out. That will burn out all of your equipment, all of your appliances. Previous Sakline.
Sir.
Have you ever heard of, তুমি কখনো শুনছো কি যে তোমার এলাকার এই যে মানে কালবৈশাখী ঝড়ের সময় তোমার এলাকার অনেকের বাড়ির ফ্রিজ পুড়ে গেছে, টিভি পুড়ে গেছে, শুনছো না এগুলা?
জি স্যার।
Have you ever heard of
স্যার
this?
আমার পাশের বাসার সোলার পুড়ে গেছিল স্যার।
Exactly. So you have heard this, right? When the lightning struck, your equipment got burned. Now nowadays this is very common. এখন কিন্তু আমাদের দেশে in Dhaka city it doesn't happen. এটা কিন্তু হয় না. It doesn't happen. But router got fried. Your router can be fried because of the lightning. তোমার router নষ্ট হয়ে যেতে পারে. Your router or your computer can be burned out. Why? Because your power line has this lightning arrestor, but your internet line, that is the wire actually, right? Your internet line do not have this facility. Okay, that's why sometimes your what is that, your router can be fried as well. So when there is a lightning, it is a very good idea to switch off everything, okay, and detach everything. When there is a lightning, remember, whether there is protection or not, but you must switch off and disconnect everything, even your router. রাউটারটাও খুলে ফেলবা, পিছে থেকে ওই যে তোমার ইন্টারনেটের কেবলটা খুলে ফেলবা. You disconnect the internet cable from your router as well, from your computer as well, when there is a lightning. Okay, now how the engineer is dealing with these? they will what is that? They will establish some sort of
858.
arrangement. Let's say this is the lightning arrestor. Okay, this is the lightning
Okay, sir.
arrestor. The one part of the lightning arrestor is connected inside the ground. This is the ground. One part of the lightning arrestor is under the ground, and another part of the lightning arrestor is with the transmission cable. So it is there after some moment, after some time, after some distance. It present after some distances. Okay, these are all lightning arrestors. They are actually there in the transmission line.
Okay, sir.
So what will happen when there is a lightning? There is a lightning. The voltage will go and discharge through them to the ground. Understand? This huge voltage will go to the lightning arrestor and will go to the ground. That's it. It will be discharged. So this will not harm your equipment. This will not go to your consumer end. Now, what will happen if there is no lightning? If there is no lightning, they can discharge your normal voltage as well. Your normal voltage or normal current can be discharged as well, right? That is a problem. But lightning arrestor is designed in such a way when your voltage is lower, that means 132 kilovolt or 250 kilovolt, that time the resistance of the lightning arrestor is infinite. Infinite means it is open circuit. No current will go to the ground. But when there is a excess amount of voltage, when the voltage is bigger, that time the resistivity is almost zero. When resistivity is zero, it is short. It's short to the ground, so the voltage will go to the ground. When the voltage is just discharged, that time voltage reduces from 1 million volt. Let's say here you have 1 million volt. When all the voltages are discharged, that time this 1 million volt become 132 again. That time the resistivity shifts from 0 to infinite. বুঝতে পারছো? Have you understood?
Yes, sir.
Okay. Okay. Now now come the
Sir, the lightning, one piece is enough, sir, for 1 tower transmission.
I didn't understand which one.
Sir, lightning
Yeah.
for the transmission line, sir, one piece enough.
Not one piece, because they are placed some after moment. Let's say 1 kilometer after 1 kilometer. Okay.
Oh, okay, sir.
Maybe something like that. Maybe 500 by 500 meter by 500 meter. Because this is expensive. You can use it after 100 meter as well. No problem. It is your wish. But it is a good idea to use before a what is that? Substation, before a substation. It is a good idea to use after a substation. It is a good idea to use it before a transformer. After a transformer, it is a good idea. Okay.
Yes, sir.
Now the insulation and support. We will learn more about this in chapter 8, because chapter 8 is more is all about insulation and support. Then we have conductor. The cost of the conductor decreases with the increase of transmission voltage. Obviously, if you increase the transmission voltage, your conductor cost will decrease because you need less conductor, you need smaller conductor. That's it. Insulation and support. Remember the voltage. If you increase the voltage, your cost of insulation and support will increase as well. Okay. So
Excuse me, sir.
you have to consider everything.
Hello, sir.
Yeah.
Excuse me, sir. Sir, on the tower there is a device called dropout fuse. May the dropout fuse and the lighting arrestor are connected in series, or they are independently to each.
Which one? Dropout switch.
Yes, sir. The dropout fuse and the lighting arrestor may be connected in series, or they are independent to
Or
each
the
other.
dropout fuse, right? You're saying dropout fuse.
Yes, sir.
Okay, let's see what is the dropout fuse. Let's see the picture. This one?
Yes, sir. Obviously.
Okay, I need to check it. Then I okay, this is the one, right?
Yes, sir.
This is the dropout fuse. Okay, I'll check it and I will let you know. I haven't seen this. I haven't seen this in my life, so I will check it. Maybe
Okay.
they will protect our power line from dropout.
Yes, sir.
Okay. Lightning arrestor is a different thing. Lightning arrestor, they actually takes out the excessive amount of voltage and release it to the ground. That's the only principle. Its principle is very simple. When voltage is small, that means normal voltage, that time the resistivity is much higher, almost infinite. That means open circuit. But when the voltage is much bigger, that time the resistivity is 0. So it is a short circuit. That time in the highest amount of voltage will discharge to the ground. So it will not move. It will not go to the some other places. It will just go to the ground directly. Got my point? So what is dropout fuse?
Yes, sir.
I will just see and I will let you know.
Inshallah.
Okay, inshallah.
Sir, on
Yeah.
wires are going out from the transformer. That three wire are three phases.
Yeah,
Actually, maybe.
Three phases, yes.
And how about, sir, the four wires which are
Four
going out?
okay. Yes. There are two connections. There are two types of connections you can use in a transformer. One is Y connection, another one is delta connection. If you use delta
Yes,
connection, delta connections are normally used for transmitting. That means from the generating station to the Dhaka city. There is a big line, right? Big line. Those are
Yes.
all three lines. Three, not four. Those are all three. All delta connections. Delta connections has three connections like this. Okay. No, wait a minute. Okay, transformer can has delta this is Y connection. These are all windings. Okay, now this one, if you take connections from this connection type, this is a Y connection. So you can take connection from Y. These are all three phases, phase A, phase B, phase C. And you can also take the connection from the neutral. This is the neutral line. So phase A, phase B, phase C, or phase R, phase Y, phase G, something like that. They have different types of name. And you can take the, what is that? This is the neutral one. Neutral means when if you ground these inside your transformer, you can use this ground as a supply as well. Supply not means this is a ground, okay? Because people will take one line, single phase, and a neutral, right?
Yes, sir.
They need it. The consumer need it, right?
Yes.
So that time you have to supply the 4-wire. That's why this is more like consumer end connection, consumer. So when you give the connection to the consumer, like from your road to your house, that time you will use this Y connection. Understood?
Yes, sir. Absolutely.
So that's why they need four wires, because you have to take from one wire and you have to take connection from the neutral. You have to take connection from another wire. You have to take connection from neutral. Okay?
Yes,
this is the rule. But if you use delta connection means, what is the delta connection? Delta connection is this one. These are all windings. Okay, so you will take connection from here, from here, from here. There is no fourth point. So this is all 3-wire connections, right? Three-phase 3-wire connection. In 3-phase 3-wire connection, normally this is not seen. You cannot see it in your city because cities are all consumer. That's why they have 4 connections. That means Y connection. But this is used for transmitting the power. Transmitting the power means from, let's say, from Sunamganj to Dhaka. This is a 200 kilometer
away.
200 kilometer away. That's why they do not need the fourth wire, because fourth wire, if you use fourth wire, that is a additional cost. So you have to understand that, and you will not use that. But when it goes near to the city, like let's say near Narayanganj or near Jatrabari, when it comes to near the city, that time you will use another step down transformer, that is Y to delta. No, delta to Y. Okay, that will convert this delta to Y. Then you will transfer that to the city. Okay, that's it. Very simple.
Yes, sir.
Okay.
Yes, sir.
Now let's move on. These are all economic choices you have to understand. Now, requirement of satisfactory electric supply. Very important informations are here. At first, remember.
Can you back?
Yeah.
Can you back for economic choice of transition voltage? That is a question.
I can go. Obviously, I can go. Which one?
Up.
What question you have?
Sir, up. Economic choice of transmission voltage.
Economic choice of transmission voltage. This one, right?
Yes, yes, sir. Sir, the first point is that if transmission voltage is increasing, the volume of conducting material required to reduce. So
Yeah.
that how it can be possible.
How it can be possible, right? Why it is reduced? But others are increasing, right? Transformer, because you need bigger transformer, you need more cost. You need bigger switch gear, that means more cost. You need a bigger lightning arrestor, that is more cost. Insulation, you need more insulation because your voltage is bigger, so you need more cost, right? But how about conductor decreases, right?
Yeah.
Okay, now this is a very interesting topic, because if your voltage is bigger, that means you need less current. Your current will be smaller, because how your voltage is bigger? Because you are using bigger transformer. Bigger transformer means it is increasing the voltage and reducing the current. Understood? Same power. For same power, it is increasing the voltage and reducing the current. When the current is reduced, that means it has what? It has less amount of voltage drop in your power line. We have already discussed about this mathematically. Let's go and find out that. Yeah, this one. Advantages of high transmission voltage. So reduce the volume of conductor material. You need less amount of volume. Okay. So there is, I already taught you these. So you need less amount of voltage, less amount of volume. That means volume means length into area. Now your length is fixed. You cannot change the length, because you cannot move your what is that? Transmission. No. You cannot move your generating station near to your city, right? That is there. But what you can do, you can reduce the volume by reducing the area. Area means you can make your conductor thinner. Understood? So how that is happening, you have to understand. When your conductor is this big, right? Let's say this is a conductor. Let's say your resistance is 2 ohm. How much? Let's say resistance is 2 ohm, right?
Yes.
And if your current is 10, let's say your current is 10. What is 10? 10 ampere or 10 watt? I do not know. Let's say it is 10. Now, what is the voltage drop in the line? Because your line have a resistance of 2 ohm and your current is 10. So how much drop will be there?
20 volts.
10 into 2, 20 volt, right? Your drop will be 20 volt. Now, if you increase the voltage, what will happen to your current? Your current will decrease, right?
Yes, sir.
If you increase the voltage, let's say your current become 20, your current become 5 now, because you double your voltage, so your current will be half. You double your voltage, your current will be half, because the same power, because of the transformer. Transformer uses the rule. If it increase the voltage, it will decrease the current. Now, for the same transmission line, what will be the drop now?
40.
No, 5 into 2,
Yes, sir. 5 to 2.
10 volt, right?
Yes, sir.
Previously the drop was 20 volt, now the drop is 10 volt. So you can reduce the
Volume.
volume. Now you can use smaller what? Thinner cable. Why? Because if you use thinner cable, your resistivity goes up. Your resistivity become, let's say, 4 ohm, right? When it was double the thickness, the resistance was 2 ohm. When it is half, your resistance is 4 ohm. Now how much drop you have? How much drop? 5 into 4. How much drop you have?
20.
20. So see, in both cases, your what? Your drop remains same, right? So you do not have additional loss. Your loss is same. But what you can do, you can save some money in copper volume, right? More copper means more money, less copper means less money. So this is how you can actually what? You can reduce the number of cost or the amount of cost in volume. Okay. Now, requirement of satisfactory electric supply. So you can say when your electric supply system is satisfactory. How can you say that? Number one, electric supply system in India. This book is written for India, so this is applicable for Bangladesh as well. Okay. The electric supply system, because this book is written by V.K. Mehta. V.K. Mehta is Indian. So electric supply system in India is 3-phase AC operating at frequency of 50 Hertz. Remember, frequency is a very important term. Your frequency must be fixed throughout the transmitting. So if it goes up or goes down, that will create a huge amount of problem in your system. So there is a system of balancing out the frequency. I am going to give you an assignment today. Okay, I'm going to give you one assignment. So you have to do some research and you have to come up with the idea how people keep the frequency balanced. So when the frequency goes up, what they do, when the frequency goes down, what they do. Okay, to make it fixed. I'm going to give you an assignment. Okay, number one, how can you tell your system is satisfactory? Number one, voltage regulation. You have to understand your voltage regulation should be plus minus 6%. It is written somewhere. It is written somewhere plus minus 6%. Okay, maybe not here, maybe somewhere else. So voltage regulation, you have to understand plus minus 6% is the limit. So plus minus 6% means someone say plus minus 5%, but this book said plus minus 6%. Plus minus 6% means if your genuine voltage is 100 volt, you can give 94 volt to 106 volt. Always remember, if your rated voltage is 100 volt, you can go up to 106 volt, or you can go down up to 94 volt. That is your limit. You cannot go beyond that. If you go 90 volt or if you go 110 volt, that is dangerous. You cannot do that. That is not reliability. Okay, your voltage regulation should be so good. Your voltage variation A voltage variation has a large effect upon the operation of both machinery and lights. Remember, your power machinery and lights has effect on your voltage regulation. If your voltage goes up or voltage goes down, they are affected. A motor is designed to have its best characteristics at the rated voltage at constant voltage. Consequently, a voltage that is too large or too low, that will result in decrease in efficiency. Obviously, your motor will lose its efficiency if your voltage is bigger or smaller. If the fluctuation in the voltage are sudden, there may cause the tripping of the circuit breaker and consequent interruption of the service. Obviously, if your voltage is high, your circuit breaker will trip and your electricity supply will be cut off for some point, for some moment. So voltage regulation is a very big topic. Dependability. So your system should have dependability. That means your system will be supplied to hospitals, right? Your electricity supply system will be supplied to hospitals, to market, to factories. They do not allow your electricity supply to fluctuate, right? Maybe there is a operation going on. Maybe some patients are on ventilator. Maybe some patients are on ICU. So if your system do not give constant power or do not give constant service, what will happen?
There will be a loss of life.
Yeah, there will be loss of life, right? If your supply system is giving power to an industry, okay, if your power goes, what will happen to the industry? It will face losses. So you should have dependability. Then balanced voltage. It is very important that the polyphase voltage should be balanced. Balanced means we as a consumer, we take single phase voltage, right? But hospitals or what is that, industry or market, they take three phase. So your phases should be balanced. If your phases are not balanced, so that will be a huge problem. Let's see what is a balanced system means. Balanced three phase voltages. What are those? See this curve. Balanced three phase means your voltage should be, that means your three phase 1, phase 2, phase 3, they should have equal amount of distancing. That means 120 volt. No, this one. They should have a equal amount of distancing between phase A to phase B, phase B to phase C, and phase C to phase A. That, what do I mean by that? I mean the distance between this point and this point should be 120 degree, fixed 120 degree, not more, not less. From this point to this point, the gap should be 120 degree. 120? 120. And from here to here, this should be 240 degree. So this is called phase, this is called balance. That means 120, 120, 120. Okay. So that is the balancing you in electrical term. So your voltage system should have a good balanced voltage. Okay. What is efficiency? Efficiency must reflect the line losses. Your voltage should be big enough so that the line drop is less. Okay, line drop.
Yes.
Frequency, very important term. Your frequency should be fixed. Because if your frequency is fluctuating, that will change the motor speed. Your motor speed will go up or go down, and eventually that will reduce the lifetime of your motor. Lifetime, okay?
Yes.
Sinusoidal waveform. Your voltage should be perfect sine wave, like this one. These are all perfect sine wave, right? But actually, what is your line voltage? See, this is your line voltage normally, okay? They looks like perfect sine wave, but they are not. They are not perfect sine wave, okay? Perfect sine wave should look like this, okay? Or this, but they do not look like in real life. They are something like this, right? So the more it become perfect sine wave, the better it is. Remember, the better it is, okay?
Yes.
So it should be sinusoidal waveform. And freedom from inductive interference. Obviously, your line should have zero inductive interference from the communication line or electromagnetic field disturbances. Okay, it should have zero interference. Okay, now we will leave this to you. Okay, remember these questions, they were actually not important when we gave normal exam. Okay, in case of normal exam, they were not very important. They were not. But nowadays, since we are giving online exam, some of your question might be very small, like one word or 2 word answer. That time, this sort of question might come in your exam. Might. I'm not saying that they will come. Not. Okay.
Okay.
Now go to the chapter 8. Mechanical design of overhead lines. Now we have one more class, right? Because we missed Sunday's class. কারেন্ট চলে গেছে নাকি? আচ্ছা